Alright, in section 4.5 we're looking at graphing sine and cosine functions, and I'm going to do two of them for you today. We are going to graph y is equal to negative 4 times the sine of the quantity 2x, 2/3 x minus pi over 3, and then we are going to graph y is equal to cosine of the quantity 2 pi x minus pi over 2, and then plus 1. And so when you look at your problem, couple things you might want to identify. Obviously I have the graph kind of set up already, but you wouldn't have that. You want to, when you go to draw this, look at a couple key characteristics. Look at the number that you see in back. It's usually the d value. It's the term that moves the function up or down. The reason I say look at that and then look at the amplitude number is that'll kind of tell you how far up or down I need to go. Since there's no number here or it's 0, I know I'm starting on the x-axis and I have to go down 4, up 4. So I have to make sure I at least go down to negative 4 and up to positive 4. So my standard graph will cover everything. If there was, say, a plus 6 here, then I know my function would be up here 6. I would be going 4 units above it to 10 and 4 units below it to 2. So I really wouldn't need all this. I would need to make sure that I cover up to 10. It just saves you time of drawing this out and then looking at that and realizing, oh wait, I have to go way down here or way up here. Obviously you don't have to. The other thing I would look at is take a look at the value that's multiplied by x, which helps us find the period, the b value. If that number does not have pi on it, then we want to use pi radians on our x-axis. If that number did have a pi on it, remember we use integer radians on our x-axis. And then also a reminder, when you're drawing your axes, try to keep these tick marks consistent from problem to problem. If you change this number to pi over here and then 2 pi and so on, you can't see the actual stretching. I know sometimes it makes it messy because it gets squeezed together so much, but please keep the same graph for every single problem. We are going by pi over 2, or basically 90 degrees, and I'm going to run through the same setup that I always do for these problems. You don't necessarily have to do it in this order. But the first thing that I always look for is I check for the new x-axis. In other words, did the function move up or down? That means I'm looking back here. I don't see a number here, or it's implied to be 0, so that means I'm actually using the x-axis. I'm not moving the function up or down. The next thing I look for is, do I have a new y-axis? And so to check to see if I have a new y-axis, I want to take what's inside the parentheses, set it equal to 0, and solve it. So I'm going to take 2x over 3 minus pi over 3, set it equal to 0, and solve it. I am, of course, going to add pi over 3 to both sides. I can multiply both sides by 3, and then I can divide both sides by 2. And so what I have found here, what that pi over 2 is representing, is that's my new y-axis. No, technically I don't have a new y-axis, but I pretend like that's the y-axis. So I'm just going to kind of lightly draw this line in here and say, I'm going to pretend now this is actually the y-axis, which means that spot right there is like the origin. And the reason we do this is if you put a new x-axis, a new y-axis, I can then disregard a lot of numbers and I can just graph it the same way we did before. Alright, next thing I want to find is probably the period. And so I'm going to take 2 pi and divide it by b, which for this particular problem our b value is 2/3. So I'm going to multiply by the reciprocal, multiply by 3 over 2, and I'm going to end up with 3 pi. Alright, so that's my period, and yes, it's important to know what the period is. That means that's one full cycle. But remember, what I tend to use is what we call the steps. And you always take the period and divide it by 4. So I kind of want to know 3 pi over 4. And what that tells me is that tells me how far I should move before I put my next point. So now all these are over 2. So I'm just going to kind of go back here and quickly throw another tick mark in all these so that I have pi over 4 in there. Again, a lot of times we don't end up with something over 4. If you had something over 6, it'd be even more painful, but here's the idea anyway. Alright, so I took care of the new x-axis. Didn't have one. Took care of the new y-axis. It was here at pi over 2. I figured out what my steps were, and now last thing I'm going to do is glance at what is the trig function and then where should I be starting. So I can see that this trig function is sine, which means I should be going through the origin. Now we've kind of moved the origin, so we're actually going to be going through this particular point here. Alright, then if I look at the amplitude, I see that it's -4, which means I should go down 4 when I put my next point. My step is 3 pi over 4, so I'm going to move over 1, 2, 3 of these little tick marks, go down to -4, put a point. Going to move over 1, 2, 3 more tick marks, go back to your x-axis, just follow your pattern. 1, 2, 3 more tick marks, go up to +4. 1, 2, 3 more tick marks, back to your x-axis. 1, 2, 3 more tick marks, down to -4. 1, 2, 3 tick marks, back to the x-axis, and just continue to follow that pattern. If I work backward 1, 2, 3, I should be up here at 4. 2, 3 more, I should be back at the x-axis. 1, 2, 3 more, I should be back down to -4. And now I've got all of my points, and I didn't have to sit there plugging and chugging numbers. I could just quickly evaluate. And now I'll put my smooth curve through it. Do the best you can to make this look like a curve and not mountaintops. And there's your graph. You can definitely see that it's been stretched vertically because that number is bigger than 1. Negative, meaning if this is my pretend origin, I'm going down first, and that makes sense. And then when you look at that number is less than 1, so my graph should be stretched out horizontally. And it has been. A little harder to see it. That's really close to 1, so there's not a major stretch to it. But there's what your graph would look like. Alright, so now if we move on to the next one. This one's asking us to graph the cosine of the quantity 2 pi x minus pi over 2. Again, I tend to look at this number, so I know I'm going to be going up 1, and then from that 1, I have to go, I have a 1 for an amplitude, I have to go above that 1 up to 2, and down 1 to 0. So realistically, my graph is going to be staying within this little window here. So did I need all this? Probably not, but I always give the same graph. Also probably notice when you look at the x-axis, I have it labeled with integer radians, and that's because my b value has pi on it. And it's just going to make things a lot easier. It's not that I can't do this. I know that pi is approximately 3.14, but it gets really, really difficult to graph when you're dealing with integer radians and you're graphing on this number line. So it's the only time that I allow you to say, okay, let's switch the x-axis. Run through the exact same process in terms of your graphing. You want to start by looking for any possible new x-axis. And I notice that it's 1 here, so I'm going to come over to my graph and lightly draw in a line right at y equals 1. And I'm going to pretend like that's the actual x-axis. Then I'm going to look for a new y-axis. That's always the second thing that I look for. It's not like I have to do x-axis first and y-axis second, but that's just what I do. So now I take the parentheses, set it equal to 0, and solve it. So I will go ahead and add pi over 2 to both sides. If I divide by 2 pi, that means 2 pi is going to eventually be down here in the denominator. So x is going to equal the pi's would cancel. It's 1/4. Which again, not great, but not that big of a deal. So I'm just going to approximate it. I know that's 1/2. 1/4 is probably right about here. Alright, so again, I am looking at that like it's my origin now. And now I can disregard all of these other numbers. All I have to do is figure out the period and the steps, and then look at my trig function, and I can graph it. Alright, so period, it's always 2 pi divided by b. Our b value happens to be 2 pi, so our period is 1, which of course is important, but for the way I like to graph, you always want to take that period and divide it by 4. So our steps are 1/4, so this means this thing is going to be squeezed together a lot, which we can tell. If you look at your b value, it's bigger than 1 by quite a bit. That's over 6. So this thing is really going to get squeezed together, and it's going to get a little bit messy, but that's okay. So I need to move 1/4. Well, that means I need to put in some more tick marks here. So putting in 1 extra tick mark in between all these gives me 1/2. I'll just approximate the best I can to 1/4. And we're not going to probably fill out the entire graph just because of how squeezed together this is and how messy this is going to get. Alright, so now I know my steps. I know how far I have to move right or left before I put a point. I can see my amplitude is 1, so I know to go up or down 1. Now I identify the trig function. I should not be starting at my pretend origin. I should be starting at +1 since it's cosine. So I'm going to be starting here. And now follow your patterning of x-axis -1, x-axis +1, x-axis -1, so on, so on. Only move 1/4 to the right, so that's going to put me here, back to my x-axis, my pretend x-axis. Move 1/4 to the right, that puts me down at 0. 1/4 to the right puts me back to my pretend x-axis. 1/4 to the right, back up to 2. 1/4 to the right, back to pretend x-axis. 1/4 to the right, back to 0, and just continue to follow your pattern out. So normally you want to try to go out a couple of curves. Like I said, don't feel the need to fill this entire thing out because this is going to be squeezed together a lot. I do like to see something the positive direction, the negative direction, so if you could, go ahead and do a couple points in the negative direction would be nice. And then, like before, put your smooth curve to it. A little tougher for this one because of the fact you've got so many curves in here. Again, just do the best you can to not make them look like peaks. Alright, and you can see that that graph has definitely been squeezed together. Hard to see it completely because we've changed the units. Like pi for us typically would be right about here. So that's from 0 to pi, which on this graph is a lot smaller. So even though we can see that it has been squeezed together, hopefully you'd be able to identify that just by looking at the b value. You should be able to identify that by looking at the b value. Alright, there's your graph. If you have questions or need any help graphing sines and cosines, please let me know.